Today on How It's Made Dream Cars, the Tesla Model S, a high-performance luxury sedan with zero emissions. Located in Fremont, California, the Tesla factory occupies more than 5 million square feet. The facility was jointly owned by Toyota and GM before Tesla bought it. The Model S runs on electricity alone. It can go almost 300 miles on a single charge. Drivers can recharge for free at a network of supercharging stations. These stations can add half a charge in just 20 minutes and up to 80% charge in 40 minutes. In 2006, the Tesla Roadster rocked the automotive world. It was the first all-electric production car that could travel almost 200 miles on a single charge. Could go from 0 to 60 in just under 4 seconds, with the top speed of over 120 miles per hour. The Roadster was a limited edition proof of concept vehicle that cleared a path for the Model S. Most electric vehicles are just modified conventional cars. The Model S is the first electric sedan built from the ground up. The Tesla Model S body is 98% aluminum. A robot transfers aluminum sheets or blanks into the drawled die of a stamping press. The upper die applies more than 1,400 tons of downward force, while the lower section exerts about 130 tons. This force stretches the blank aluminum sheet over the form in the center of the lower die. Robots move the part from station to station. Each panel undergoes a series of procedures before emerging on the other side of this gigantic structure. The structure is called the tandem press line. Workers inspect each finished panel to ensure there are no flaws and that all openings have been cut. The tandem press line is capable of exerting more than 11,000 tons of force and creates 5,000 parts every day. Tesla uses state-of-the-art technology to build the Model S's undercarriage. Here, a robot brings the car's front, center, and rear floor panels to the frame. A team of robots use CMT or cold metal transfer welding to join the parts. With the floor panels in place, the underbody moves forward on the line, and a pair of robots install the body sides. The body sides are the complete sides of the Model S. They feature high-strength, steel-reinforced B-pillars. Next, the sides are joined at the top by a pair of headers that can span the width. These will complete the basic structure of the car. Tesla uses several methods to join the car's body components, including cold metal transfer welding, conventional spot welding, structural adhesive, and self-piercing rivets. A worker now attaches the door panels. They each have 2 hinges attached with 4 bolts. Like most of the car, the lightweight doors are made of aluminum. The total weight of the aluminum used in the Model S is just over 410 pounds. The front fenders go on before workers install the hood. Since there is no engine, the front hood is really just a cover for the front trunk space. The body of the car is now completely assembled. It is what manufacturers call a body in white. A technician gives the body in white a thorough inspection, checking all weld points and structural adhesive joints, as well as the overall fit and finish. In the paint department, the car body goes through a pre-treatment process. It's essentially a bath for the car and a giant dishwasher. Once clean, the body receives a corrosion-resistant electrolytic coating, a primer, a base coat, and a clear coat. When the 6-hour process is complete, 3 separate teams of inspectors examine the surface to ensure its quality. It may not look like it, but this Model S's powertrain has already been installed in its undercarriage. The car's drive unit sits snugly between the rear wheels. It may be small, but it cranks out over 400 horsepower. Tesla Motors builds most of its car components in-house, including the AC, or alternating current motor. This step in the production process is called the stator wind line. A machine unspools and winds over a half-a mile of copper wire for each motor. An electric motor consists of a stator and a rotor. Here, a machine begins building a stator by pulling the copper coils into a structure called a stack. This is a 3-phase motor, so there are 3 separate coils of copper. When in use, a current will pulse through each coil, creating a temporary magnet. The rotor will turn because its magnet follows the stator's magnetic field. This worker carefully lengthens and straightens the ends of each bundle of wires. This is so he can insert the hydraulic lift needed to move the stator to the next phase of production. For the motor to work properly, the bundles must be insulated so the phases don't touch each other. A technician insulates the copper wire by carefully encasing each one in a protective sleeve. While much of the production process at Tesla is completed by high-tech machinery, this step is so important, it's best done by hand. For all its futuristic qualities, the Model S has a few old-school elements. The motor, for instance, is a direct descendant of the 100-year-old motor developed by Nikola Tesla himself. A worker snips the ends of the copper bundles to prepare them for the next step. These components are called lugs. A worker slides them over the wires where they will be crimped, forming the attachment points for the motor's 3 phases. You might be surprised to see a sewing machine on the production line for an electric motor, but that's exactly what this is. Tesla uses this highly specialized device to bind the coils securely in place. The more tightly bound the wires are, the more efficiently the motor will work. This binding process also prepares the stator to be encapsulated in a 2-part epoxy, locking everything in place. The 2-part epoxy provides an extra layer of insulation, evenly distributing the motor's heat. The completed stator easily slips inside a heated metal casing. As the casing cools, it contracts firmly in place. Next, a technician uses a hoisting system to insert the rotor inside the stator's opening. The completed AC motor moves down the production line to another station, where a worker installs the differential. The 3 lugs that are attached to the stator's 3 phases protrude from the top of the motor. Now, the worker attaches other sections of the gearbox in place. Thanks to its well-designed motor and inverter, the Tesla Model S can rely on a simple gearbox rather than a complex transmission. Not only is the gearbox more efficient than a transmission, it's far smaller, leaving more room for storage space. A technician conducts an air leak test on the motor and gearbox before the next phase. worker now prepares another crucial component of the drive unit, the three-phase tripole inverter. The Model S motor requires an inverter to convert the battery's direct current electricity into alternating current power. Every Tesla Model S drive unit must undergo a dyno test. In this test, two components of the dyno machine plug into the drive unit. The dyno tool then tests every parameter of the drive unit to ensure it meets all design criteria. This test takes just 4 minutes. Every 4.5 minutes, a new drive unit comes off the production line. From here, the drive units head to the general assembly area. From the outside, the Tesla Model S resembles other high-performance luxury sedans. But the general assembly process reveals some intriguing features that make this all-electric vehicle unlike any other car in production. Battery-operated carts guided by magnetic strips in the floor carry the cars through assembly. Technicians install tubes on the underside of the car that will carry coolant to the battery. This will prevent the battery cells from overheating. The technicians also install the high-voltage cables that power the motor. Then a worker lowers the car with a hydraulic lift, preparing it for the next step in production. A robot installs the car's roof. Customers can choose a panoramic roof for their Model S. This all-glass top is constructed of lightweight safety glass that blocks 80% of the sun's heat and 100% of UV rays. A technician begins building the frame for the instrument panel. The frame is one of the few components made of steel in this aluminum-bodied car. The instrument panel needs to be steel because it is the main interface between car and passenger. The panel requires a more dependable structural integrity than aluminum provides. It holds everything from the radio tuner and amplifier to the airbags and touchscreen controls. This touchscreen is central to the Model S's driving experience. It's like an onboard tablet computer that allows the driver to control all aspects of the car's performance. Using the touchscreen, you can access the rear-view camera, raise and lower the car, open and close the roof, adjust the brakes, choose the car's performance mode, monitor energy consumption, and fine-tune the sound system. Maps, music, and the internet can also be accessed all with a single device. The touchscreen is always up to date, automatically downloading the latest browsers when one becomes available. In the general assembly area, a technician installs the instrument cluster screen and touchscreen in the instrument panel. It is upholstered with a synthetic leather. Next, they add air vents and other components. The instrument cluster above the steering wheel will show speed and power use. The driver can also choose to monitor other functions on the display, including energy use, sound system, and phone info. Workers use a hydraulic hoist system to install the completed instrument panel. The hoist helps prevent worker injuries and minimizes the chances of any damage being done to the panel during assembly. Technicians install the 12-way power-adjustable heated front seats. Drivers can access many of the touchscreen functions directly from the steering wheel. A worker raises the Model S's drive unit up under the car and secures it in place. The drive unit fits into the rear axle assembly. It provides power directly to the wheels, so there's no need for the usual drive shaft. Finally, it's time to install one of the car's most unique features, the battery. Since Tesla designed the Model S from the ground up, they were able to turn the challenge of battery storage into an asset. The lithium-ion battery weighs almost 1,200 pounds, running the length and width of the car. The battery adds strength and rigidity to the car and lowers its center of gravity. This improves the Model S traction and handling, as well as its safety rating. Technicians mount the 19-inch forged aluminum wheels. In conventional cars, the internal combustion engine provides the power to turn the wheels. But most of that power is lost to heat, friction, and tire rolling resistance, leaving a drive efficiency of 35% at best. Thanks to its incredibly efficient drive unit and sleek aerodynamic design, the Tesla Model S has a drive efficiency of nearly 90%. When a Tesla Model S is complete, it rolls off the assembly line and onto bamboo flooring, a fittingly eco-conscious floor material to showcase this highly efficient zero-emissions car. The Tesla Model S is fully assembled, and technicians have installed all of the car's firmware. It's nearly ready to drive. The Model S may look like other luxury sedans on the outside, but there are certain details that reveal just how different this electric car really is. Since there's no hot engine to cool down, the Model S has what manufacturers call a nose cone, instead of a traditional front grille. Also, there's no tailpipe or gas cap. Technicians now begin to give the Model S a complete inspection inside and out. They test every aspect of the car's functionality and thoroughly examine the fit and finish. Once it passes inspection, a driver takes the car for its first drive. Tesla builds all of its Model S cars to order. This particular car is destined for an overseas customer, so the steering wheel's on the right-hand side. At this next station, a worker performs a roll test. During this 5-minute test, the technician brings the car up to speed, checks the brakes, and sets the alignment. Most cars would also get an emissions test. But since the Tesla Model S doesn't have any emissions, there's no need to conduct this test. Next, the car undergoes a water test. As high-pressure water drenches the car, the inspector examines the interior for any signs of leakage. The car's low center of gravity helps it maintain traction in wet weather. The electric drivetrain has low inertia, allowing it to adjust quickly to changing road conditions. In cold weather, drivers can use an app to preheat the car before stepping in. Finally, the Model S is let loose on the Tesla test track. To ensure the car meets its design parameters, the driver gives it a thorough road test. Here, it can flex its electric muscles. Despite the compact size of the car's drive unit, it can accelerate from 0 to 60 in just 5.2 seconds, with a top speed of 120 miles per hour. For a sedan, The Model S has a remarkable amount of space. With the seats folded flat, it has over 63 cubic feet of total storage space. Using the touchscreen, the driver can customize the car's performance right down to its ride height and steering mode. Onboard maps show the closest supercharging stations, and the car keeps close track of its energy usage. With a drag coefficient of 0.24, the Model S is one of the most aerodynamic production cars in existence. This contributes to the car's ability to travel almost 300 miles on a single charge. Tesla is leading the way towards an emissions-free future with this truly electrifying car.